Hey guys, this is Steve Rain again. We're going to go into the second part of our tour of the Oracle XC architecture. Again, we're just going to take an overview of relating the files that you can see on disk in your Oracle XC installation to the overall architecture of the database and describing what pieces of the things you can see on disk are related to some of the concepts we discussed in the lecture. In a previous video, we spent a lot of time on the memory structures and background processes, the so-called Oracle instance that comes up in memory when Oracle is started. And today we're going to spend a little bit more time looking at the actual files where data is stored on disk. So I'm going to jump in here to take a look at on disk. And if you remember that Oracle XC stuff is stored by default, well, at least on Windows systems, in C Oracle XC. There are a variety of folders under there, and we discussed some of these last time, but I'll take a tour through some of the things that I did not get a chance to present very much in our last video. Let's see. Okay, so I put the magnifier up just in case it's helpful for folks to be able to see at my screen resolution what's going on. See, here's kind of the Oracle directory tree here, app, Oracle, admin, XE, and we see a bunch of folders here. They all have, or most of them have, dump in the end of the name. I'm going to look at two in particular. One that will become very important to you if you're doing DBA work is bdump. Bdump stands for background dump destination. And you can see that a lot of database logging at a general level happens here. The most important file in here by far is alertxe.log. This is the so-called Oracle alert log. When significant database events happen, they get written to XE. This is kind of like the general database diary for system-wide events of any importance, startups and shutdowns, that sort of thing. You'll see that they are recorded in the alert log. I'll open this guy and put this guy in front here. Okay. Move the magnifier over. Sorry. Okay, so you should be able to see here. I'll bump up the font a little bit. Make it like 20. Okay. This is the contents of the alert log, and you can ignore the magnifying window for a moment, but you should be able to see a little bit of what's happening in the alert log. So here's a record, for example, of the database starting up. You see all the parameters with which it started up get recorded in the log. There's all kinds of it records things about where it's writing data, etc. We won't explain every line. We'll just sort of talk in general about the kinds of things you can find here in the alert log. And if there were any major system errors, those would get recorded in here as well. Again, startups and shutdowns will show up. If you have a major error or something that would shut down your database, this would be the first place you'd check. Like, so you can see, for example, way back on June 9th, I'm not even sure what this is, but it says errors in file blah blah blah, open failed for members of log group 2 of thread 1. And we'll talk a little bit later about what that sort of thing means, but you can generally find helpful information, as I said, information about significant events in the life of the database, and somewhere up here, we just passed one, there is a description of such and such database or such and such file is X% filled. So if you find interesting information like that, if you are having a problem with your database, again, going to the alert log is probably one of the best things you can do offhand, and it will give you a good bit of information. There you go. So it tells me that a certain area on the file system that is sized at such and such an area is X% used, and other interesting pieces of information like that. So the alert log here in background dump destination, now looking at the magnifier again, is probably useful. That will be a good way to look at significant events in the life of the database. You also see these so-called trace files here, and these are more information about events that are significant in the life of the database. They're not as critical as some of the alert files, but you will see these. You can use these in more advanced tuning administration scenarios that we're not going to go into right now, but be aware that they are also in this bdump destination. The general theme there is that the background dump destination is used for system level things, and that's where the database writes general system level information. In contrast, the udump directory down here has other sets of trace files. These are things that are going to be typically specific to a user's session. You're going to want to use these a lot in tuning scenarios, and a little bit later in the course we're going to cover performance tuning. But the trace files you find here are going to contain lots of session-specific information that is useful to tuning various SQL statements, etc. Now, I haven't created any such files yet in this Oracle XE instance, so there's really not much worth showing you here, but just in terms of understanding the file system and where things are, know that this is a pretty good place to go. When you go to do performance tuning, you're going to be looking in the udump destination, where you're going to find all those session-specific trace files. Let's take a little bit of tour further down. Doc is nothing terribly interesting. I believe some documentation things. I'm going to come back to flash recovery area in a minute. Let's go down a little bit further. And we had said earlier that most of the data for our database is going to reside in this XE directory down here, Oradata XE. If I go in here, I see a lot of files that end with DBF. Each of these files is a so-called tablespace. A tablespace is kind of a logical collection, logical bucket, in which we can store data on disk, and it maps to one or more files at the operating system level. The way these tablespaces are set up, there is only one tablespace, or excuse me, only one file for each of the tablespaces in the operating system, and a little bit later on I can show you the process of creating a second tablespace, or excuse me, a tablespace with multiple files. But let's just take a quick tour through these guys and see what the deal is with them. We'll start with the system.dbf. This is the so-called system tablespace. Oracle, as a relational database, stores everything it knows in tables. Well, mostly everything that it knows. Even information about what tables you have defined, permissions on those tables, etc., are stored in the so-called system catalog. System.dbf is the tablespace that contains the system catalog. And that's where all the information that Oracle uses for its own internal management, again, the brains of Oracle per se, live in this particular file. If you lose system.dbf, it would be like having brain surgery on Oracle. The data that you store in your applications, you would define tables for employees, departments, and all the other traditional database examples and those sorts of things, would go in a tablespace like users.dbf or others that the DBA might create. Users.dbf and similarly named table spaces are places where we would keep application-specific data. Again, system.dbf is reserved or should be reserved for Oracle's internals, its structure, the tables that it comes with by default to manage itself. Users.dbf is things that we want to use for application-specific code. The tables that we want to create as part of our line of business applications, they would go in users.dbf or other table spaces we create for that purpose. But we want to keep these two things, Oracle's brains and data that we store for an application, separate from one another. Sysaux it's related to system, but I guess over time Oracle had a bunch of tools and non-essential components of the database that would create various table spaces, etc. Sometimes they were in systems, sometimes they were in other table spaces that were named specifically for them. So the goal here, that Oracle tried to collect all that stuff, these non-essential components of the database, and have them use this so-called sysaux table space. We're not going to spend much time with that during the course of the term, but you should be sort of familiar with what it is. Okay. Up here, the control.dbf file is a critically important database file. It's not a table space per se, although it lives amongst the table spaces on disk. Control file is sort of the master directory of where things are in the database. As we discussed in the last video, when the database starts up, it reads the parameter file and it knows how to size things in memory, what settings to use, etc. The next thing looked at is the control file. The control file is the file that says, okay, so my system table space is at C, Oracle XE, Oradata XE, system.dbf. It knows where the other table spaces live. Basically has information about where all the various files that comprise the database are, so that Oracle can go and find those, read those, etc. But the other important function, well, there are many functions, but probably the other very high-level important function performed by the control file is that it contains so-called system checkpoint information. When you make changes to the database over time, the database increments a small counter. For every change that it accepts, it says, such and such a table was updated, so and so a certain user was added to the database, etc. Things like that. The database will increment a counter called a system change number. And when the database has some sort of failure, a database crashes and it starts up again, it does a consistency check. And it goes through the control file and transaction logs, which we'll look at in a little bit, and all these different table spaces, and it says, hey, is everything up to the same system change number? What's the latest system change number I have recorded, the last one that I know happened, and are all the data files in sync? All the data files have these checkpoint areas in them where the database will go through and say, okay, I know you're consistent up to system change number 1000. You're consistent up to system change number 1001, etc. So the control file is kind of the master record of what system change number things are up to, and it can synchronize the various table spaces and the various data files. If it finds an inconsistency there, if one area says that everything should be up to system change number 1002, but it finds that one of the data files, for example, it is only current through system change 1000, the database goes into a little recovery step where it tries to apply transactions from the transaction logs to the data files to make everything consistent. But again, location of things and change number records are both stored in the control file, and change number records also appear in other places in the system. But the system change number and the location of things, kind of like a database directory, those are sort of the two main functions of what the control file does for us. Down here is the temp tablespace. Temp is kind of like Oracle using its own virtual memory. Oracle has to do a large sort, and it can't keep all the information. A sort is a memory-intensive operation, and if Oracle can't keep all of the data that it needs for the sort in memory at the same time, it will write this out. It will write that out to this temporary table space that's represented by temp.dbf there. And again, it's kind of like the paging or virtual memory concept that any traditional operating system would use. Oracle does its own internal memory management, and it uses the temp table space in the same way. It'll write certain things to disk as part of sorting operations and other very memory-intensive operations. We will look at undo.dbf. This is what used to be called rollback segments in Oracle parlance, if you ever hear the term rollback. But it's basically, undo is a good name for it because it's a way that Oracle stores previous versions of things that are in flux, things that are changing. If you are making a change to the database, you are changing, let's say, a set of records, Oracle actually maintains different versions of the associated blocks, the low-level operating system units of input and output that it's reading and writing. Different versions get stored so that Oracle can provide read consistency for people, which is to say, if you're making a change and you're in the midst of a change, you haven't committed it and made it publicly available to everyone, you're looking at one version of the data, but everyone else who comes in while your operation is in progress, they're going to see a different version of the data. Oracle maintains these multiple versions of the data by relying on the so-called undo area or the undo table space. And that's what's kept in undo.dbf there. We are up to the table spaces at the top here. You can see 2K, 4K, and 8K underscore ts.dbf. Those were example table spaces that you can see in the lecture I created as one of the demonstrations of different performance characteristics of different block sizes. I created 2K with a 2K block size, 4K with a 4K block size, etc. But again, this is an instance of table spaces that would be created by the database administrator, in this case me, and these would be to store application data. And again, these are the three that you can see created from the performance example in the slides.